Okay, so on this next one, this is the greatest integer function with the double bars, and you can find it in your calculator under math and then choose number, and then number 5 is integer for greatest integer. And so what you need to type into your graphing calculator, because I want you to see it in there since using the stylus just kind of sucks on this, guys. And so in y1, I want you to type 0.75 minus 0.5, and then you're going to go get int, and then you're going to type in negative t plus 1. So I distributed the negative sign. And then you're going to set your domain up so that it goes, so your x min is 0 and your max is 5, counting by ones, and then your y min, it doesn't really matter. I did, I think, like -4, -3, I think, and then the max goes to +3 just so that I could see all of it. And then I want you to actually look at it. And if you notice here, I made a table. Of course, x doesn't really get to be 0 because I've got an open circle around it, so I really can't even count that point. But that is what was in the table. So this extra little green dot that I put here shouldn't even be here. There should be nothing there at all. So all you're seeing is little staircases, and that's typically what a greatest integer function looks like. So that's all I actually had to do for this one, was just graph it. Just keep in mind that a lot of things in life actually work on a greatest integer function. Usually things like I call the plumber and I have him come over. He charges me $40 an hour, and then plus however long it takes him to do the job. So just for showing up to my door with his smiling little face and his tool belt, I paid 40 bucks, and then, you know, half an hour I pay the extra hourly, 3/4 of an hour I pay the extra hourly, an hour I pay the extra hourly. But if I go to an hour and 10 minutes, then I'm going to pay for 2 hours. So it works like a step function. There are a lot of things in real life that work on step functions. Okay, moving on to the next one. So now that you have that C of t in your graphing calculator, I want you to go back to your table set and make it so that the independent is ask. And then I want you to put these values in and write down what your y values are. So we're trying to figure out what's happening as x gets closer and closer to 3.5, but I want you to actually find the values using your graphing calculator. So hopefully you got the same values that I got, and so we can see that, of course, if I come in from the right of 3.5, getting closer to it, all the values are the same. And then when I come in from the left, all of a sudden they start getting closer and closer to 2.25. So when I come in from the left and the right, and even at that value, I get all the same values. So the limit as t approaches 3.35 is 2.25. Stop the video and fill in the next one. So on this one, I noticed something a little suspicious as I approach 3. So this is the number I was looking at getting closer and closer to 2. And I mean closer and closer to, not the number 2. So as I approach 3, from the left-hand side, I notice that I'm getting closer and closer to 1.75. And as I approach from the right, I notice, oh, it's 2.25. And so all of a sudden there's this big hike and change in the numbers when they weren't very far off here, but they are far enough off here and definitely different. So there must be a jump in this, and so therefore my limit does not exist, since the values from the left and right are not approaching the same number. Okay, so now if I graph this next one, 4 minus x, it's just a line, has a y-intercept of 4, a -1 slope. And I'm looking at what's happening as I approach 3 from either side. So if I notice, as I get closer and closer to 3, it looks like there's a number right there from the left. And as I approach it from the right, looks like I'm getting close to that same dot. So my value must be 4 minus 3, which is 1. So the limit is 1.